Welcome to Sequences and Sets. After completing this lesson, you should be able to describe the various kinds of sequence collections and their properties, outline the desirable properties of the vector collection type, and describe the properties of set collections. So what is a sequence? A sequence is an ordered collection of data where duplicates are permitted. There may or may not be index such that you can access a value directly into it without having to walk the entire collection. And some of the common types you find in sequences are arrays, lists, and vectors. The apply method when you have an instance of a sequence is a lookup at that index. So consider an array. Arrays are fixed in size and they are an ordered sequence of data. They are very fast on the JVM and on other platforms because they are always contiguous in memory and data can be prefetched down to the cores of execution at the time instructions are going to be executed. Arrays are also indexed by their position. So an example of a Scala array, we create an array using the companion object apply method and we put the values of 1, 2, 3, 4, and 5 inside of it. This gives us an array of ints. Because arrays are zero-based, when you access the third value inside of the array, you actually look it up with a 2, because the first element would be 0, the second would be 1, and the third would be 2. However, if we try to access something beyond the size of the array, such as going with the result 0 and indexing it at the fifth element, which is actually the sixth position, we are not able to access a value or try to set the value because we are outside of the array's size. Here is how we would operate on arrays. We use the companion object apply method to create a new instance of an array by saying array with the values of 1, 2, 3, 4, and 5. Arrays are zero-based, which means that the first element is accessed with 0, the second element with 1, the third element with 2, etc. So when we say result 0 sub 2, we are accessing the value 3. If we tried to update this array, and all arrays in Scala are actually mutable collections, if we try to update the element at the fifth position, which is actually 6 because this is a zero-based index, if we try to change that value, we get an array index out of bounds exception because the array only had 5 elements, and the last one would have been indexed at 4. Scala's lists are a linked list implementation with a value and a pointer in every cell. The pointer points to the next element or next cell with another value if there is one. They are theoretically unbounded in size, though that isn't entirely true because there is always the limitation of the amount of memory that the JVM is allocated or on the machine. There is some performance hit in using lists because data could be located anywhere in memory. Every time you go from cell to cell, it could be going anywhere else in memory, and that means you are accessing data using pointer chasing, which can lead to stalls at the core of execution. However, compared to arrays, they're very flexible because you don't have to worry about if I exceed the size of a list. I only have to worry about how much memory I have. In this case, again, I use the companion object apply method to create an instance of a list. And I put the values 1, 2, 3, another instance of 3, and 4 into the list. Because sequences can have duplicate values, this is not a problem. I can get rid of the extra 3 by using the distinct method on the instance of the list that was created. However, if I look at the original result 0, you'll notice it was not changed when I did that distinct operation. Instead, a new list was created using the exact same references to the values that we were using before. If we want to add a value to a list, we can either append or prepend, and there are operators that allow us to do that. However, because lists are sequences where order matters, we have to use an associative operator. And in this case, you'll notice that when we have res0 and we want to append the value 5 to the end of it, we have to have a colon plus operator where the colon faces toward the sequence. If we want to prepend a value in front of the sequence, we have to use the plus colon, again with the colon facing toward the sequence. So we say 0 plus colon res 1, resulting in a value of a list with 0, 1, 2, 3, and 4. Vectors are unique kinds of sequences in that they represent a combination of both arrays and lists. Vectors are comprised of 32-element arrays, and as you add more elements than a single array can hold, it actually creates a structure of arrays that point to one another. There are 2.15 billion possible elements, and every operation you perform on a vector is effectively constant time. Vectors are indexed by hashing, and they give you good performance characteristics across all operations. What is a set? A set is a bag of data where no duplicates are permitted. No order is guaranteed inside of the collection, and common usages of sets include hash sets, tree sets, bit sets, key sets, and sorted sets. There are more as well. The apply method on a set, instead of giving you a value at a specific place inside of a sequence, instead tells you whether or not the value exists in the set, because there is no order to a set per se. Here's an example of a set. I create the set using the companion object apply method, and I put the values 1, 2, 3, 3 again, and 4 into it. This results in a set of 1, 2, 3, and 4. Because we already had 1, 3 inside of it, we didn't need to have a second one. Sets are unique sets of values. You can see that the default implementation of a set that we get whenever we create one using the companion object apply is a hash set. And because there's no associativity or order, when we want to add a value to a set, we don't have to reference its position, whether it's prepending or appending. We're merely throwing a value into a bag. So we say result 0 plus 5, and it puts 5 into the collection of set. However, if we then want to add a value that already exists, it results in no change. Here we have an instance of a set 1, 2, 3, and 4. We can check to see whether a value is inside of that set by using the apply method on the instance that was created, result 0. If we say result 0 sub 5, it's checking to see if 5 is inside of that set, and we get false in return. If we check to see if 2 is inside of it, we get true. If we take that result 0 and want to make it an ordered sequence of values, we can use the toSeq method. And then we can take the resulting sequence and convert it back to a set by calling toSet on that instance. Having completed this lesson, you should be able to describe the various kinds of sequence collections and their properties, outline the desirable properties of the vector collection type, and describe the properties of set collections.